Good morning, everybody. It's great to be back in the land of enchantment here in New Mexico for ISPCS and the Jamboree and Rodeo. I always love coming back to this conference. It's a great place for me. I've been coming for a long time and a big-time supporter of this event. I'm glad to see it grow and thrive and continue today. This morning you heard from George Sowers talk a little bit about philosophy. I'm going to talk about evolution. Another dangerous subject. Maybe, Barry, you can take on gay marriage later on. I don't know. So I'll try to keep this fast. I'm going to talk for about 20 minutes. We got some time for Q&A at the end. I'm going to talk a lot about the evolution or revolution of what's going on in both the satellite and the launch industry. So I'm going to talk about it from a perspective of a launch services provider working for Arianespace, and talk about it from the perspective of my customers and what's going on in the satellite business and how we have to adapt our launch systems and our launch services offerings to be able to provide services to these operators who a lot of times actually don't even think of themselves as space companies. They think of themselves as data companies or entertainment companies or companies that are looking to leverage what is really a very high platform of space to do things here on the ground and make money at that, really. I often tell people that in the business side I'm in, most of it is commercial telecommunication satellites. I mean, 90% of what is commercial space today. Now, that is evolving. We're seeing a lot of change in that area. We're seeing companies get into data in remote sensing areas. We're seeing a lot of the companies here talk about personal commercial space flights for actually putting people in suborbital and orbital flights. But today, the primary markets have driven still by communication satellites. So I'm going to talk a little bit about that evolution and where it's going. So Pat asked me not to do a standard corporate presentation today, which is always dangerous for me. I didn't get these slides approved by corporate, so we'll see how it goes. So here we go. You get a lava lizard for your first slide, right? You don't see many space presentations start with a lava lizard. So naturalist Charles Darwin posited in his famous work, The Origin of Species, that populations evolve over generations in order to survive. So what you have here is the Galapagos lava lizard, who has evolved to blend in with its surroundings and even drops off its tail if it's captured by a predator. And that's how it has survived over time. And so in the space business, we need to continue to evolve to keep pace with this. So next slide is the obligatory dinosaurs being killed by an asteroid slide, right? So Steve Jobs, everybody knows who Steve Jobs is, right? He said that companies decline when quality becomes less important to them. So today, there are fewer than 70 companies from the original Fortune 500 that are still on that list today. So that's 14% of the original Fortune 500. So what we've seen is a huge decline. A lot of companies, a lot of brands that I grew up with, companies like Westinghouse. Where's Westinghouse today? National Cash Register, Digital. I mean, there's a lot of companies that have evolved or changed. You see here some very famous brands, Polaroid, Blockbuster, Circuit City, Kodak, Pan Am, brands that are no longer with us, but are iconic brands that we thought these were companies that were bedrock companies that would never leave us. So focus on quality. So Arianespace. Arianespace has been doing launch services for 34 years. Originally founded in 1980 as the world's first commercial launch company. When I say the commercial launch company, that is the primary focus of the company from its founding was launching commercial telecommunications satellites, not doing space agency missions, although that was a huge driver for Europe when they founded the system, was to be able to launch their own satellite systems. But in fact, it was the Symphony satellite that started that all, which had a telecommunications payload, and they wanted to launch it through NASA, and NASA said, wait a second, we're not so sure. We want you launching a telecommunications satellite. And so Europe went off and created their own launch system and started doing launches with the first inaugural launch of the first Ariane 1 was done on Christmas Eve of 1979 from the Guiana Space Center. And the way it works in Europe is a little bit different than the COTS program here that's more recent in the US. Is the development was done at the time and it continues to be done by the European Space Agency and the other member space agencies, that organization. So it was done by ESA, CNES, the French Space Agency, and other space agencies in Europe. And then once the system was tested in flight, it's handed over to Arianespace to commercialize it and sell it in the marketplace. So what you see here is one of the Ariane launches, with the early Ariane launches. And this was really the beginning of the commercial launch part of what we did. This is Intelsat 507 flying on October the 19th of 1983. It was a satellite that was built by Ford Aerospace. There you go. Now, when was Ford doing it, right? They're building cars, but they were building satellites back then. Had a mass of 1,928 kilograms, so fairly small by today's standards, in fact. Tomorrow I'm actually leaving here to go to Intelsat tomorrow for the launch of Intelsat 30, which is about a 6 metric ton satellite. It's about 3 times the size. So you see in 30 years, we've gone 3x in terms of the size, and those satellites are much, much more capable today and increasing in performance. So we had to evolve the launch systems to be able to continue to serve our customer base. So you see here a chart of the evolution of that original Ariane system, starting with the Ariane 1, which flew 11 times successfully between 1979 and 1986. The Ariane 2 flew 5 successful missions between 87 and 89, and Ariane 3 made 11 successful flights between 84 and 89. All 3 launches were slightly different, trying to increase the capability. So the first and third stages of the Ariane 2 and the Ariane 3 were stretched so that they had more performance, and then we added on strap-on boosters, a variety of liquid and solid strap-on boosters to increase the capability and performance up to about 2 metric tons. But still at the end, satellite manufacturers and operators wanted bigger, larger satellites. They started building bigger spacecraft, and we needed to introduce the Ariane 4 to be able to take on that capability, that service offering. So at the end of the Ariane 4 era, which Ariane 4 launched 113 times successfully, it had a 97% plus success rate. It was considered the highest quality launch system at the time when it was retired in 2003. So I was actually with the company then when we were still flying it, and we retired the Ariane 4. And the last mission we flew was for Intelsat on 15th of February 2003, and that was a 4.7 metric ton system. And so we had a great rocket. So why did we have to retire it? Well, satellites were no longer 4.7 tons. Then they were 5 and getting closer to 6 tons in the marketplace. So I'll tell you a little bit of a story about a revolutionary satellite operator. This is the story of a guy named Rene Ansamo, if you haven't heard it. Rene was a guy who founded Spanish language programming television stations across the United States. So Channel 62, Channel 43 here, doing Spanish language broadcasting back when it wasn't as big of a deal as is now today with Televisión and all the other Spanish language programming that you find in the United States. So he was actually forced to sell his network, and I like the acronym, right? The Spanish International Network, SIN. He was forced to sell SIN by the FCC because of some foreign ownership restrictions. He had some foreign investors. And he decided to take that money that he made from that, to put all his chips in the middle of the table, and to build and launch his own satellite. Now at the time, you weren't allowed to do international satellite services competitively. It was done through an organization called Intelsat. Today, Intelsat is a private company, but back in the day, Intelsat was an international treaty-based organization founded to be able to provide international satellite communication services. So he wanted to go out and compete against these guys, and he went to RCA, the satellite builder at the time, again, another brand that's now no longer with us, right? And he bought what's called a whitetail satellite, so a satellite that was half built for another customer, but then they ran out of money or changed their plans. It was sitting in the factory. He took that satellite, he went down there, wrote personal checks to the guys at RCA, do a little bit of work on the satellite, keep building it, and tailored this thing as a digital platform that was going to provide television service from Latin America back into the US, and primarily television service. At the time, telephone traffic, Intelsat was concerned about them competing on telephone. Can you imagine telephone traffic? You remember those old calls over satellite where there was the echo delay? You had to wait for the other guy to talk before you could actually speak. So that was actually part of their core business. But this guy was going to do all digital television. So he got our bargain price to fly on the first Ariane 4 rocket. So we gave him a deal. And basically, the story goes that he had either little or no insurance whatsoever. So that if, for some reason, the satellite didn't work or the launch didn't work, he was going to be darn near broke. But this guy does this. He pushes all his chips in the table. And of course, as it turns out, it's a tremendously successful effort. By the way, he had to take out full-page advertising in the Wall Street Journal and the New York Times and Washington Post. And he created this cartoon dog named Spot. And Spot was very prominent in all this advertising they did. The guy was kind of crazy like a fox, to be honest with you. And he had this cartoon dog named Spot. and sometimes he was riding on the back of it, tilting at windmills, like a Don Quixote kind of character. And it was a little cartoon. And he would write an open letter to President Ronald Reagan at the time. And he said, "Dear President Reagan, it's not fair. My dog Spot says I should be able to compete in this international marketplace. You got to let me compete. You should change the rules so I can compete." So he does all this. He builds this company. Ultimately, he sells it to leverage buyout from KKR for $4.3 billion. Now you see on the far left of the slide a slogan, and that was the official slogan of the company, if you can believe it. I actually have a poster in my office with that on it, official. So, like I say, crazy like a fox, but for $4.3 billion, you can do it how you want it, right? So satellites got bigger, and we needed an Ariane 5 to be able to carry those. We couldn't do it anymore with the Ariane 4. So we started the Ariane 5. When it debuted, it was about 6.3 metric tons of performance, which was really the biggest satellites that were out in the marketplace at that point. Today, it can launch over 9.5 metric tons in dual launch. And so since the very beginning, I didn't mention this earlier, but since the Ariane 1 through the Ariane 5, our philosophy has always been to dual launch, that is multiple manifesting. We put multiple satellites on a single launch system, and we do that for a very simple reason. The economics bear out that it makes it much more efficient and much cheaper to launch large telecommunication satellites for our customers. So the Ariane 5 system today is a dual manifesting system. We do well over 9.5 metric tons to GTO. We have over 20 metric tons of performance to low Earth orbit. We did our last of 5 missions to the space station this year with the ESA's ATV system launching this past summer. We currently have the lowest insurance rates in the business. We do about 6 to 8 of these launches a year, so you start to do the math with double manifesting, and so we're launching typically 12 plus geo telecom satellites a year. We also do scientific missions, so we're launching, in fact, the James Webb Space Telescope in partnership with NASA and ESA in 2018, which will be the follow-on to the Hubble, and an amazing machine being built by Northrop Grumman, and we're looking forward to doing that mission. So we also have the Soyuz vehicle, the venerable Soyuz, yes, the Russian-built Soyuz that's launched over 1,800 times. We brought it to French Guiana down in South America, where we launched 5 degrees north of the equator. And this system has been modernized and adapted to fly from the Guyana Space Center. It does about 3.2 metric tons to GTO, although we've used it primarily not for GTO missions, but for sun synchronous orbit and MEO missions, primarily for launching constellations of satellites. So a company called O3b, which stands for the other 3 billion, is a launch we did in June this year, and they're trying to connect the other 3 billion people on the planet that are not connected to the internet with a satellite broadband constellation. We also did the Galileo launches. Unfortunately, the most recent of those that we did this summer did not work properly. We had an anomaly with the upper stage. We think we identified the cause of that, and we're going to return to flight in December. And we're looking forward to launching O3b in December from the Guyana Space Center. But to address an even smaller market, the revolution that's going on in small sats and CubeSats, we have the Vega launch system, which is a small launcher. It does about 1.5 tons of performance to sun synchronous orbit. We've had 3 successful flights, debuted on February the 13th of 2012. And again, it has a dual launch system. Their structure inside the Vega is called the Vespa. So if you want to think about this, we have an Italian scooter riding inside a 1970 GM car. I didn't name it, all right? So I'm not responsible for that, but I remember these things. So it's tailored for CubeSats, small sats. We're looking at a lot of those exciting markets. You heard George Whitesides talk about that earlier this morning, and we think there's a lot going on in that market segment, and I'm going to talk a little bit about some of those companies in a moment. We do have a very exciting launch coming up for ESA in November, the Intermediate Experimental Vehicle, the EXV, as they say in French. You can see it pictured here. I don't want to say it's like the X-37B, because I'll have people from Boeing yelling at me because it's not, but this is their demonstrator version. This is a small space plane lifting body concept that they're going to use to put into space, and the idea is to develop a reusable craft that's capable of operating with modular payloads, multiple applications, and eventually to land it on a runway. So this is the idea from Europe, and it's pretty cool. We're very excited about the launch. It's going to be taking place in mid-November. If you can see from the picture, it's about 5 meters, about the size of an automobile, if you can imagine. And the idea is to really to be able to evolve this thing over time, launching it with Vega, and have a really interesting capability down the road. So, in summary, for Arianespace, total, and this is the end of the commercial, I promise, 492 payloads placed into orbit. We've launched over half of the telecommunications satellites that are operating in geostationary orbit today. We've had over 90 public and private companies entrust their spacecraft with us. Currently have 31 customers in our order book and roughly $5 billion in backlog. So we're doing pretty well right now. If you've heard rumors of our demise, we're not dead yet. We're still chugging along. So let me talk a little bit about the evolution then of the company. I talked about the vehicles here. So I've only been with Arianespace for 13 years. The fly is going to get me. But some of my colleagues have been there for all 30 plus years of Arianespace. And they tell me the story about how we started. Hopefully this is going to work. I hate animation and slides. You never know if it's going to work or not. There we go. We started competing with the space shuttle. That was our first competitor in the launch marketplace. Then came the Delta II. And Commercial Titan, if anybody can remember that. The Atlas 2AS, great launch system. We competed against the Chinese when they entered the marketplace with the Long March family. Then Proton came along into the commercial launch business. And the Zenit rocket with both sea launch and land launch. We saw that evolve to, please go, there you go. The ELVs entering the marketplace. You see the Delta IV Heavy here. And then ultimately, Falcon. So Barry, here's a commercial for you. I actually put the Falcon 9 in my presentation. So the idea is that we've evolved over time. We've competed with those. We've seen those market entry. And what we've done is adapted our launch system so that we continue to compete. And we plan to continue to compete for the future and to be around for another 30 years. So as I mentioned, the market for satellite services, I'm going to shift gears a little bit, stop talking about rockets and start talking about satellite companies and what they do, it's an applications-driven business, right? It has been from the very beginning. So satellites at the beginning, I talked about delivering telephone traffic, but really it was video that was the main driver, right? The Thrilla in Manila, the boxing match that was broadcast around the world, Muhammad Ali, was delivered live via satellite. If you can remember those early days of the satellite business. And it was driven by delivering video feeds around the world. Well, soon that became delivering programming to cable head ends around the world. And that was a huge driver for the satellite business. And then ultimately that turned into direct broadcast satellite. I'll talk a little bit about that. But the other networks that they did was like VSAT terminals. So if you go by a car dealership or drugstore, gas station, a lot of times you see a small satellite dish on top. That's a private network that's being connected via fixed satellite service. So when you're doing your pay at the pump, boom, it's going over a satellite link. Cellular backhaul is now a big part of that, taking all the mobile devices that are now in areas where you can't get that content delivered out, all that data out and in. They're being used with satellites. And now the next thing coming is high throughput satellites. So some of the operators up there that we've served over the years, by no means an exhaustive list. Mobile satellite services came along. So companies like Inmarsat, Thuraya, then Globalstar and Iridium. The original idea was connecting ships at sea and remote locations. The terminals got smaller, the user equipment got more efficient, got it down to handset size with Iridium and Globalstar. Then into the market for satellite radio with Sirius and XM, so moving into automobiles. It's one market, by the way, where you can't run a wire, right? So satellite's always going to have an advantage here, being able to deliver this content. The idea is to be able to do more and more with mobile platforms through satellites. I talked a little bit about direct broadcast satellites. So you know some of these companies, Dish and DirecTV, Astra in Europe, and these companies brought with them new technology, new capabilities, the advent of the digital video recorder, the DVR system, and portability with technologies like Slingbox, all through an 18-inch dish put on your house. Sometimes you can self-install it. So this was quite a revolution. In fact, the first time DBS came out in the 80s, it was a failure. So it was really actually the second generation or third generation, if you want, of that system, driven a lot by the consumer electronics companies at the time, RCA Thompson and Sony and others that developed inexpensive set-top boxes that really revolutionized that business. I flew down to French Guiana a couple of years ago with some guys that were launching a DBS business in India, and they were dramatically changing that business model. For us, it's $100 probably a month. You can get a subscription for lower, but my DirecTV bill is $100 a month, and I originally had to pay for the box to be installed and a technician to come out. And so, but in India, they've got that box down to $40. And there's no back office. There's nobody when you call. All the billing is done through the cell phone, and the guy just pays through his cell phone. If he wants to order a cricket match, he can do that through his cell phone, and the coding goes back up through the satellite and decodes on the box, and boom, he's done a pay-per-view with the cricket match. And they can make that work with a revenue of about $60 a year for that one box, so dramatically changing that business model. Broadband satellites were next, right? So I talked a little bit about one of the companies on here, O3B. Point-to-point is difficult with satellites, but we're getting better at it. And satellites are becoming bigger, more capable, more powerful, and being able to deliver more content with higher throughput systems. We've seen companies like WildBlue, which we launched their first spacecraft, Viasat, HughesNet, which is now owned by EchoStar, and we launched their Spaceway spacecraft, and then the O3B constellation I talked about that we're just launching. We've done 2 launches for them so far, and a 3rd coming in December. But companies like Facebook and Google are now talking about these types of broad networks. So you've got Google that's got this Loon project. I don't know if any of you guys have read about this, about balloons flying 20 kilometers or so above the Earth, high altitude solar powered UAVs. They purchased a company here in New Mexico called Titan Aerospace. So they want to look at different kinds of platforms, maybe even satellite platforms, to be able to connect all these billions of people on the Earth that are not connected today. Similarly, Facebook has their project with the likes of Ericsson, Qualcomm, Nokia, and Samsung, where they founded internet.org, and they have their connectivity lab where they're putting together plans of their own. They've also bought their own drone company. I know a lot of people don't like the word drones. Remotely piloted aircraft, I guess, is the better term for that. But they want to provide low-cost internet. So their business models, by the way, are very different than the one that DirecTV employs with me, where I pay a subscription. I mean, these guys are looking at eyeballs on websites, on clicks, on advertising. So it's monetized in a very different fashion than you can imagine in a traditional way of satellite services. And then we've got, hopefully, does it work? Oh, there we go. Wait for it, wait for it. There we go, big data. So big data. Everybody's talking about big data these days. What does it mean? So we've got a lot of new companies out there. You may have read about some of them in Space News and other trades, but Space News is the best because they're sponsoring this session. So there's other companies out there like Planet Labs, like, come on, gotta work. There we go. Planet IQ, Google Skybox, OmniEarth, GeoOptics, Canopus Systems, and these are just a few of the ones that I've read about or talked to that are looking to launch systems that are going to provide remote sensing services, imagery, or other data sets, everything from hyperspectral imagery to full motion video from space, and taking those data sets and then incorporating with all the data that we have on the ground, right? We all have cell phones today. It's providing massive amounts of data, and being able to harness the powers of computers and software today that analyzes those huge data sets, and then is able to take that data and create models out of it that are going to tell us other things. So stuff that we don't even know what we don't know yet, but these data models and analytics are going to be able to drive us, and we're going to be able to use that information to do better things here on Earth. So these are just a few of the applications types of things you see out there. There's companies that want to do better weather forecasting using technologies like GPS occultation, hyperspectral imagery, precision agriculture. Tom, I think that's one of your images up there from Skybox. So there's a lot of stuff they can do to be able to make life here on Earth better. So that's a little bit about what's going on in satellite. So anybody know what that is, what that picture is right there? Jawbone? Eric's got one. Eric's got one. So this is one of these Jawbone Fit bracelets that are out there. So I was talking to a woman up in Toronto last week at the IIC who's taken this, this approach, this type of technology. Come on. There we go. And she made it big for a cow. So here we are at the ranch here. Think about taking one of these things and making it big and putting it around the neck of a cow. So what can you do with that? Well, you can track the health and position of the cow. So you can go to the rancher, And you can say, I'm going to give you a bunch of these things for free, and hang around the neck. You got 10,000 herd of cattle. We're going to put them on 400 or 500 of your cows, maybe the sickest ones in the herd, or the ones that aren't doing so well, the ones you really want to monitor their health. And we're going to use GPS, satellite technology. We're going to use cellular and automated identification system links through satellites. And we're going to be able to track that herd. Right? And we're going to be able to tell how they're doing, what their health is, what they ate, where they walked, what they did. Right? And I'm going to give you the positioning stuff for free, but I'm going to create a tiered system of services if you want to know more, right? With more of that data set. Right? Now, think about that. You got the 10,000 herd. Maybe you got all of South America. Then you got all of the world. Now you got a huge data set. Think about the people who might want to buy that data, right? Right, commodities traders, people trading meat in the markets. So it's an amazing thing to be able to take that. So here's the young lady. She's how old is she, Ariane? 27-year-old engineer from Uruguay. And she's got a tremendous future ahead of her. Patented technology, by the way, so don't think you can steal it or whatever. You know. She knows what she's doing. She's already got patents for this, and she's won several awards. But it's a really neat way of talking about taking satellites and monetizing that. So the road ahead. What do we see for the future? What's going on? How are we going to evolve to stay close to this evolving satellite marketplace and where it's headed, both for launch vehicles and satellites? So let me talk first about where the satellite business is heading. What we see right now is the advent, or I should say the advent, it's the increased utilization of electric propulsion for satellites. So electric propulsion's been around for decades, in fact. It's been used for satellites for station keeping for a very long time. What's revolutionary now is people are talking about using it for orbit raising. So that is no longer just to keep the satellite in its proper box when it's flying in space, but actually raising it from a transfer orbit into its final orbit. So today, on a typical satellite, more than 40% of the mass is bipropellant. It's hydrazine, monomethyl hydrazine, that's used to do the orbit racing of the satellite, to circularize its orbit and put it in the final operating position, and then to use that propellant also to do station keeping on orbit. If you can use xenon ion engines, Hall effect thrusters, SBTs, to be able to keep that satellite in place, but also to raise it in place, you can gain 40% of the mass back on the platform. So that dramatically reduces the mass of the satellite being placed in orbit. And that is a huge challenge for launch services providers and how we're going to adapt our systems to be able to carry these satellites into space. The one drawback of this, by the way, though, is it's a lot more time in transfer orbit. So satellite operators, manufacturers have to build that into their models, flying through the Van Allen belts, for instance. No one's quite sure, in fact, what the effect is going to be over time. But it really is something that could dramatically change what we're launching, how we're doing. So for Arianespace, what's going on? We're getting there on the Ariane 6. You may have read a little bit about that in the press. The Ariane 6 will be the next generation Ariane system. It's up to the European Space Agency and its member state space agencies, so CNES, DLR, OSI, and other major space players in Europe to decide on the funding for that. It's supposed to happen at the December ministerial meeting in Luxembourg. But they've come up with a common approach right now. They've all gotten together with the industry, with Arianespace, and with a joint venture that was started between Safran and Airbus, which are our two prime contractors for engines and the launch system. And they've gotten together and decided on two versions of this Ariane 6, a 6.4 and a 6.2 version. The 6.4 would have up to 11 metric tons of performance. And the 6.2 would be able to launch institutional missions to different types of orbits. And the idea is to use a building block approach with solid boosters that could actually be taken and then used on the Vega launch vehicle down the road. So we have a path forward. Hopefully we're going to get the funding through ESA set forward. And the idea is to have that system ready in 2019, 2020 to be able to compete in the commercial marketplace. So that's where we are today. I'm going to leave you with one last quote from paleontologist and evolutionary biologist Stephen Jay Gould, that evolution is a process of constant branching and expansion. There you go. Thank you.